Hello all, today in this video I'm going to make a demo for MLP classifier. This is a continuation video only. Previously with the same dataset we have worked with many machine learning algorithms, and in this work we are going to make with the MLP machine learning algorithm, that is MLP classifier, and going to compare with another machine learning algorithms which we have made so far, and will make an comparison with the a bar plot to make to show which machine learning algorithm is providing better results. For that, initially we are loading the data set. This data set we have downloaded from Kaggle. You can just check as email spam detection. Kaggle dataset means this dataset you will get. It is having nearly 3 entries, which is unnamed one, email text and email type. In that you may notice we are getting the info of the dataset. From that you may notice that this email text and email type is the object type, and the unnamed is an integer type. Then we are checking whether we are having any null values. From that you may notice that the email text is having some 16 null values. Then also if you notice means this unnamed integer, which is unnamed column, which is an integer, it's just a serial number, so we no need to make use of it. So we are going to drop it, and also the null values from the data set which we are having. For that we are using the drop function, drop now function, and drop duplicates function. Again we are checking the missing values. Now we may notice that we have removed this unnamed column, and also it is not, now the data set is not having any null values. Then we are checking the shape of the data set. From that we are getting nearly 17,538 entries in the data set. Then we are making a plot for the email type, which is having nearly two classes, which is safe email and phishing email. From this plot you may clearly notice that this safe email is having some better or some higher count when compared to this phishing email. Then we are using the train test split function to determine the variables like xtrain, xtest, ytrain and ytest. Before that we are determining or declaring variables like x variable and y variable. For x variable we are calling the email text, and within the y variable we are calling the email type. And also within this, by using the test size 0.2, that is 20% for testing and remaining 80% for training, we are determining these variables. Then previously we may see that this email text and email type both are in text only, so we have to convert it into vectors. For that we are using the tfidf vectorizer. By using this we are converting our xtrain and xtest variable into vectors. This vector value only we are using in every model training and evaluation. Since this every algorithm we have explained previously, we are just going to make and skip procedure only. Why? Because if you want to see the explanation of this particular algorithm means, you can just skip to the previous video, because this is a series video only. For every separate algorithm we have made a series. So now we can just move to the just a preview. For that this logistic regression we are determining for every algorithms we are determining the predictions, confusion matrix and classification report. So this accuracy is 96. Then for support vector mission the accuracy is 98. Then for catboost classifier the accuracy is 97. Then for passive aggressive classifier the accuracy is 96. Then for random forest the accuracy is 97. Then for naive Bayes the accuracy is 94. Then for KNN the accuracy is 73. Then for decision tree the accuracy is 91. Then for gradient boost the accuracy is 94. Then for Adaboost the accuracy is 93. With XGboost we have converted this email type variable to this numerical. Why? Because this XGboost will work only with the numerical data in the y variable also. So we have replaced phishing email term as 1 and safe email term as 0, and then we have done the further processing. For few further example, you can just see the video for XGboost, and we have got an accuracy of 97. Then we worked with XGD classifier and got an accuracy of 97 only. Here we are going to work with the MLP classifier. By that we are getting an accuracy of, initially we are determining this uh, library. Then within this library we are calling within a variable. That variable we are using for the training and testing. Training is done by use of the training variables and the fit function, but testing is done by use of the testing variables and the predict function. Then we are making use of a confusion matrix. Here some things confusion has taken in confusion matrix, so we are not getting this confusion matrix. It's not an thing. The only issue is done. It's while making some headings, we just made it as it as this line as a heading, so I has not run, but I think we haven't noticed it. Then we have displayed the classification, and we have got 96% accuracy. And this is the bar plot for this confusion. This for all the algorithms we have made so far. For that, for SVM, we have got an accuracy of 98%, which is high. For the algorithm, which is we have declared now, we have got only 96% accuracy. It is not much low, because the very low classifier which we have done is KN. So this is the algorithms which are machine learning algorithms we have done so far. In the next video, we will be working with some deep learning algorithms with the same data set. Thank you.